Uh, differentiability. So the last thing we're talking about is differentiability. So differentiability is kind of like continuity. Continuity said, is a function continuous, right? We did continuity last chapter. It was the last thing we covered last chapter. Even though it's not the same, it's very similar. Differentiability means, does a function have a derivative at a point? Or does it not have a derivative somewhere? So it's kind of like differentiability. The way we check it is similar to differentiability, or sorry, to continuity. Okay. So differentiation. So differentiability means we can find a derivative. It has a derivative. Okay. It has a derivative. So if I was to actually find the derivative at a point, could I get a number? Could I get a slope? Or would I get undefined? Something where I couldn't find. So 3 conditions for something to be differentiable, to have a derivative. The first thing, it has to be continuous. Okay. So if it's got discontinuity, if it's got any kind of discontinuity, like I can't find a derivative at that hole. There's no derivative at a hole. There has to be a point there. Okay. Asymptote, I can't find the derivative at an asymptote. I can't find a derivative at a jump. It has to be continuous. Okay, so that's the first rule. So it has to be continuous. We know how to check continuity. We did that last chapter. The next one is no sharp turns. No sharp turns. So what sharp turns mean are these two guys here. So at this point here, I'm going to make a red dot here and a red dot here. Those are sharp turns. At that red dot, there are 2 sharp turns that make that red dot. Okay? There are 2 sharp turns at that red dot that make it. The left one here is called a cusp point. Cusp point. Okay? It's kind of got a curve coming in and a curve going out, but when they meet, they kind of meet at a sharp point. Okay? Or a corner. This is more of a corner. 2 lines meeting at one point. So if they look anything like this, you can't find a derivative. It has no derivative. I can't find the derivative at either of those red dots. Okay? That's what I mean by sharp points. Okay? And then the last one is no vertical tangents. No vertical tangents. So if your tangent line, if the tangent line is vertical, if your tangent line is vertical like this, it's not going to have a derivative because the slope of that line there is undefined, right? I can't find the slope of that guy there because it's undefined. Okay? That's the opposite of horizontal tangents. Okay? So the easy way to check, this is the way we're going to check. The easy way to check to see if something's differentiable is we're going to find the derivative at a point going in from the left. And then we're going to find the derivative on the other side. If they're equal, it's differentiable. If one is not equal to the other, it's not differentiable. So this is kind of like continuity. The only difference here is this has derivatives. So we got to find the derivative, right? Same thing we did with continuity. The only difference is we're finding derivatives instead of just continuous. Okay? Okay, so this little table kind of explains the relationship between continuity and differentiability. Okay? So differentiability implies continuity. So if you know something is continuous, or sorry, if you know something is differentiable, if you know something has a derivative, it has to be continuous. Okay? But the opposite is not always true. If you know something is continuous, it doesn't necessarily mean it's differentiable. So just because something is continuous doesn't mean it has a derivative. Right? I could draw some like these two guys. Those two guys are continuous, but they don't have a derivative here, and here. Okay? So those are examples of things that are continuous, but don't have a derivative at a certain point. Okay? So if a function is differentiable, so that means if it has a derivative, if you've checked it, it's got derivatives at a point, then it also has to be continuous. Okay? If a function is continuous, it's not necessarily differentiable. It means you have to check it. Don't assume that just because it's continuous that it's also differentiable. But if it's not continuous, then it can't be differentiable. There's no chance. So if it's differentiable, it has to be continuous. If it's continuous, you still have to check to see if it's differentiable. If it's not continuous, then it can't be differentiable. Okay? Okay, so let's start with continuity, because they're going to ask you questions about continuity today again too, just as a little review. Okay, so continuity. We said see, where did we write it down? The limit as x approaches a point from the left has to be equal to the limit as x approaches a point from the right as the answer itself. Okay, so let me write this down. So for it to be continuous, this is continuous. The limit as x approaches a point, we'll say for f of x, from the left has to be equal to the limit as x approaches a point from the right. If those two are equal, that means it has an overall limit at that point. For it to be continuous, it also has to have that same point as an answer. Okay, that's how we checked continuity back in last chapter. Okay. Finding if something has a derivative is exactly the same thing, except instead of f of x, change all of those to f primes. If you were to change all of those f's to f prime, that's how we check for differentiability. We're not checking on the actual function itself for differentiability. We're checking on the derivative. So that's the difference. That's the difference. You can see? Very similar. Just the derivative instead. Derivative instead of the actual function. Okay. All right. Okay, so let's look at number one. Example number one. Okay. Determine whether the function is differentiable, continuous, both, or neither. So we have four options. Differentiable, continuous, both, neither. Okay, so we have four options. Okay, so we have to show why it is or isn't. Okay. It doesn't matter which one you start with. You can start with differentiable, you can start with continuous. It doesn't matter which one. I'll start with continuous, checking continuity, because we've done that before. Okay, so I'm going to check continuity for this guy here. So continuity. So we have to check the limit as x approaches. Where's the only place that this could have some discontinuity? Where's the only place that this guy could possibly have discontinuity? 14, right? 14. That's where it changes. That's where it changes from the top function, which is a quadratic, to the bottom function, which is linear. Quadratics are always continuous. Linear functions are always continuous. So we're going to check 14. Okay, so let's check 14. I'm going to plug in. First thing I'm going to check is to the left. And then I'm going to check 14 to the right. If those two are equal, that means the limit at 14 exists. And then I have to check the answer at 14, right? If those four guys are equal, it's continuous. Just like we did last. This is exactly like we did last chapter. Okay, so first one I'm going to check is from the left side, from the negative side. I'm going to plug in 14, but what do I plug it into? Where do I plug in 14? Yeah, to the top, right? Because that's less than. That's where the less than 14 comes from. So I'm going to plug it in to this guy here and see what I get. Okay. Okay, so 14 squared plus 7 times 14 minus 20. Let's see, 14 times 14 is 196. Plus 7 times 14 is 98 minus 20. So 196 plus 98 is 194 minus 20 equals 174. Did I get something wrong? Let's see. Oh, 290. Yeah, sorry, 274. Thank you. Yeah, yep. Almost. Okay. We're going to check. Now we're going to check the next one. 14 from the right side. So to check 14 from the right side, which one am I going to use? The bottom. Yep, because that's from the greater side. Okay, so let me plug in 14. 20 times 14 minus 6. 20, see, so let's see. 10 times 14 is 140. Double that would be 280. So 280 minus 6 is 274. Those two guys are equal. And if those two guys are equal, that means the limit is 274. Okay. 3 so far check out. The last one, f of 14. How would we find f of 14? Or have we already done it? Yeah, plug it into the top one, right? Because that's where it's equal. We've already done that, right? And we got an answer of 274. So this function is continuous. We know it's continuous. Okay? So let's write down so we don't forget. Continuous. Okay. Now we have to check differentiable. Now I'm going to check differentiable. So when I check differentiability, I'm only going to check at 14 again because quadratics, there's no problem with that. They don't have any corners. Quadratics don't have any corners, right? Quadratics are just parabolas. So that's fine there. And lines, they don't have any corners because they're just lines. So I'm not worried about inside. I'm not worried about anything other than 14. So the only place I'm going to check is 14 for differentiability. Okay. Can't give myself much room. Let's see. Let's see. Let me move down here. Example. Okay, so I'm checking differentiability. Okay. So differentiability means derivatives. So the first thing I got to do is find the derivative of f prime. Cool. F's got two parts. All right. F's got two parts. F has x squared plus 7x is minus 20 when x is greater than or equal to or less than or equal to 14. And 20x minus 6 when x is greater than 14, right? So I got to find the f prime. How do I find f prime if it has two parts? It's easier than you think. How do I find the derivative of f? Take a wild guess. How do I find the derivative of f? Yes. So I can't plug in until I find the derivative. So how do I find f prime? I'm going to plug in, you're right. But how do I find f prime? It's a lot easier than you think. Well, how do I find the derivative of the top? Or what is the derivative of the top? What's the derivative of the bottom? That's the derivative. That's the derivative. You just find the derivative of one piece, you find the derivative of the other piece, and you're done. So the top is 2x plus 7, and the bottom is just 20. Okay. Okay, so there's the derivative. So I did the f prime part. Now I got to do the c part. So what I'm checking to see if the derivative coming into 14 is the same as the derivative going out to 14. Okay, so differentiability. So this is how I'm going to set it up. F prime of c as x approaches c from the left is equal to f prime of c as x approaches c from the right. Okay, so what is c for this problem? For this problem here, what I'm about to do, what is c? This is f prime. That part, check. Now we got to figure out c. What is c for this problem? Let me go back. What was c for this problem? What is c going to be for this problem? 14. Yeah, that's all we're going to check is 14. So instead of c, we're going to write 14, 14, 14, 14. Okay, so how do I find f prime of 14? From the left or from the right? Either one. How do I find, let's start with this guy. How do I find f prime of 14 as x approaches 14 from the left? Use which one? I'm going to use 2x plus 7, the same one I used from the left the last time. So I'm going to use 2x plus 7. What am I going to do with 2x plus 7? You're right. I'm going to use 2x plus 7. How specifically am I going to use it? Plug in 14. So the slope at 14 on the coming into 14 from the left is going to be 28 plus 7, which is 35. Okay. Now, how do I do this guy? F prime of 14 from the right. Plug it into the bottom, right? What's the problem with plugging it into the bottom, though? It's not a problem, but what am I going to get as an answer? 20. Got to know where to plug it in, right? Those two guys are not equal, right? So what it's saying is the slope coming into 14 from the left is 35, but after I leave that dot, it changes slope. So it comes in like this, and then it comes out like that. What's that going to create at 14? Starts with a C. It's going to come in. If this dot represents 14, it's going to come in like this, and then it's going to go like that. It changes slope. Well, what does that make there? Starts with a C. It's on the first page. Corner. It's going to make a corner. It's going to make a corner, yeah. Because of that, it can't be differentiable. So we say not f of x, not differentiable. At x equals 14. Continuous? Yes, absolutely, continuous. But at 14, there's going to be some sort of corner. There's going to be some sort of corner there because of the changing slope. Entering 14, leaving 14 has to be the same. Okay? So in this case, it was continuous, but not differentiable at 14. Okay? Okay, so let's try number 2. Check continuity. I want you to check continuity on number 2, because number 2 is very similar. So since you've done continuity many times, I want you to check continuity. So continuous, it's continuous at -2, because the limit as x approaches -2 from the left is equal to the limit as x approaches -2 from the right, which is the overall limit, which is also equal to f of -2. Okay. All right. So now let me check differentiability. Differentiability. So I have to check f prime of x as x approaches, oops, that's f, c, so the first thing I need is a derivative. Okay. So let's see. 2x plus 11, 7. Okay. So the only place I'm going to check is at -2 again. 2, negative 2, negative 2, negative 2. Okay, so from the left, I'm going to plug it in to 2x plus 11. So I get negative 4 plus 11, which is equal to 7. The bottom is already, the derivative of the bottom part, 7x plus 20, was already 7. So that's just going to stay 7. So it's differentiable at negative 2. So we say f of x is both continuous and differentiable at x equals negative 2. It's both continuous and differentiable. It's both. Okay. So that's how to check differentiability. It's very similar to what continuous was. So you guys have had experience with that. Now they're going to kind of change it up. Not change it up. They're going to kind of throw a couple different things at you. Kind of like what we did on the other one. On the last chapter. Where they say, hey, something is differentiable. It is differentiable. I want you to find what A and B are equal to make it differentiable. So we've already checked it. It's differentiable. Right? It's very similar to the ones we did for continuity. Where is it? What value has to go in for A to make it continuous? We know it's continuous. What value has to go in A to make it continuous? It's the same thing. The only difference is here, it's differentiable. Okay? All right. So if it's differentiable, that means we're going to get the same thing, right? So differentiability. F prime of C as x approaches C from the left equals F prime of C, x approaches C from the right. What is C going to be for this guy? What's C going to be for this guy? Negative 2. Okay, so negative 2. We already know it's differentiable, so we already know both of these are going to be equal. So before I plug it in, what do I need to do? Before I plug in negative 2, what do I have to do first? Find the derivative. Yeah, I haven't found the derivative yet. F prime of x. A and B are numbers. A and B are values. I just don't know what the values are. So we don't treat A and B like derivatives, or like, I don't treat it like x and y. So the top 3ax, the derivative of 3ax plus 3 is just 3a. 3 times a. Because a is not a variable like x is. The bottom, it's going to be 4bx minus 1. Okay. Okay, so plug in negative 2 to the top. Where do I plug in negative 2 to the top? Which one am I going to plug it into? 3a or 4bx minus 1? Which one? The first one, right? The top one. So do I plug it in for a? No, I can't plug it in for a because it says plug it in for x. I don't have an x. So if I don't have an x, I can't plug it in anywhere, right? So my answer is just going to be 3a. The next one I can. I can plug it in for x. So it's 4 times b times negative 2 minus 1. Negative 8b minus 1. I know those two are equal because it said it's differentiable. Being differentiable, it's differentiable. So I know these are equal. But my question was to find a and b. So how do I find a and b? Well, we're going to do what we did last chapter. We did this last chapter. I believe one of the multiple, I'm not sure, can't remember, one of the free responses was like this, where you had to find one of the letters. Well, if something is differentiable, what else do we know about it? It's also continuous, right? So what we're going to do is, to help us find a and b, we're going to have to check continuity as well. I know it's continuous. I absolutely know it's continuous because if it's differentiable, it has to be continuous. But the reason I'm going to check continuity is because I don't know what a and b are. I can't solve for a or solve for b unless I know one of them. Okay, so I'm going to check continuity. Let's see, the limit as x approaches negative 2 from the left equals the limit as x approaches negative 2 from the right is equal to the overall limit for f of x, and which is equal to f of negative 2. Okay. So first one, I'm going to plug in negative 2 to the top. I'm going to plug in negative 2 to the top. So it's 3a times negative 2 plus 3. So it's going to be negative 6a plus 3. Now I'm going to plug in negative 2 to the bottom. Two b negative 2 squared minus negative 2 minus 3. Those are going to become positive. So I have 8b minus 1. 8b minus 1. Negative 2 squared is 4 times 2 is 8. Then I have positive 2 minus 3 is negative 1. Those two guys are equal. We know those two guys are equal because it's differentiable. If it's differentiable, they're also continuous. And then when I plug in f to negative 2, I'm going to get the same answer as I did on top. Negative 6a plus 3. So I have to solve for a and b. We did this last chapter. So to do that, I got to get A and B on the same side. I have to get A and B on the same side. So let me get another sheet of paper. This is example number 3. So I have 3A equals 8B minus 1. Oops, negative AB. We've got to get A and B on the same side. Negative 1. Okay, there's my first guy. The second one is 8B minus 1 equals negative A plus 3. Okay, so I'm going to add 6A to both sides, and I'm going to add a 1 to both sides. So I get 6A plus 8B equals positive 4. I'm going to use both of those to find out what A and B are. So last chapter, I used something called elimination. That's what I'm going to do again today. I'm going to stack them. My goal with elimination is when I add straight down, either A or B make 0. So if I were to add straight down, I'd get 3A plus 6A, which is 9A, plus 16B equals 3. So what I want to do when I add straight down is one of these guys to go away. So what do I have to do to one of them? Or what could I do? There's different answers. There's lots of different answers. But what's probably the easiest way, the thing I could do? Make one of them negative, because then which letter would go away? B's, yep. So you make one of them negative. Doesn't matter, top or bottom, doesn't really matter. I'll make the top negative. So I got to distribute, oops, not a negative 3, negative 1. So I'm going to distribute a negative 1. It's okay as long as you do it to every term. Bottom stays the same because I don't need that one to change. Now I can add straight down. Now when I do that, I get 3A. B's go away, which I wanted them to, equals 5. Divide by 3. A equals 5/3. Got half my answer. How do I get B? Plug in 5/3 anywhere you see an A. Doesn't matter which way. I see A's everywhere. Pick one of them. Pick one of them. You can pick the very first one we started with. You can pick the second one we started with. You can pick this guy. You can pick this guy. You can pick this guy or this guy. Doesn't matter which one. Pick one of them. Plug in 5/3 for A. Okay? I'm going to pick this guy down here, which is the same as this guy down here. I'm going to choose these two because they're both, everything's positive. Everything's positive there. So I'm going to plug in 5/3 for A. So let's see. When I do that, I get divide them both by 3. So I get 10 plus 8b equals 4. Subtract 10 from both sides. Divide by 8. B equals negative 3/4 when I reduce. Negative 3/4. And you're done. Okay. Okay, so we're not going to finish the last, or not the last problem, because we have other practice problems that I want to do. But this one right here, number 4, what I want you to do is get your 2 equations. Get your 2 equations like I did. I got 3a plus 8b equals -1, 6a plus 8b equals 4. I want you to do that, and then we'll finish it tomorrow. Okay, so the last thing I want you to do, you got about 10 minutes. Find out what your 2 equations are going to be for number 5. And then tomorrow we'll finish it. So what are your 2 equations going to be? Start with differentiability. You know it's going to be differentiable. Okay? No, not today. So the 2 equations I got, a equals -20b plus 5, and -5a minus 6 equals 50b minus 20. So tomorrow, first thing I'm going to do is I'm going to use elimination to get rid of one of them and do like I did. But those are the 2 equations I got. Okay. Okay. Uh-huh.